So the next question is actually a review question. So when does the ball hit the ground? So what do I know about the ball hitting the ground? Do I know position? Do I know velocity? Do I know acceleration? Well, sure, if it hits the ground, I know that its position is 0 feet. So I just found the position function was this. And so if I substitute this in, I'll have 0 equals, and so then I have a quadratic, and I can do some math magic on that. Can probably pull out an 8 or maybe even a -8. Oh, I guess I could have pulled out a 16. Ooh, let's pull out 16. Let's pull out a -16. And so then when I factor, I get t is 5 and -1. And of course, I can't hit the ground at -1 time. So I get t equals 5 seconds. That's a review question. I would trust that you have no problems answering that question as of now. So this too is a review question. A little bit different notation. Usually we haven't used x and x prime and x double prime, but that's just a notation issue. And so when I look at this, I go, ooh, let's see, that's the original function. So if I want to find velocity, I've got to take the first derivative on this. Remember I said this was in fact review. And so when I do it, I get, remember that you're using product rule, so I had to do first times derivative of second plus second times derivative of first. And so here's my velocity. Notice it is an expression. And now if I want to find acceleration, I have to take the derivative of that. So double prime would be 6t minus 14. The one that took the most work, of course, was velocity. Okay, so again, remember that if the particle is moving to the right, that I know that velocity has to be positive. So I'm going to take my velocity function and I'm going to factor it. So check my math, but I believe this is correct. And so I get, of course, if I set it equal to 0, I'll get 3 5/3. So I've got a test. Now remember, we were working between 0 and 5. So starting at time 0, and let's see, I believe 5/3 is smaller than 3. And then we'll go to 3, and our last interval will go to 5. Oops. We'll call it velocity. And so here, let's see, I'll test 1. Here I'll test 2. Here I'll test 4. And so if I test 5/3 and I plug it in, I'll have a negative, excuse me, if I test 5/3 I'll get 0. If I plug in 1, the first one will be negative and the second one will be negative, so negative times a negative is a positive. And if I plug in 2, the first parentheses will be negative, but the second one will be positive, so a negative times a positive is a negative. And if I plug in 4, the first parentheses will be positive, the second parentheses will be positive. Positive times positive is a positive. So now I know that Here it's moving right because the velocity is positive. Here it's moving left. And here it's moving right again. So the final answer would be on the intervals 0 to 5/3 and 3 to 5. And that was all just review. And so also when it says find the velocity when acceleration is 0, well, the first thing I have to check is when is the acceleration 0? And so my acceleration was 6x minus 14, and if I set that equal to 0, oops. Oh my goodness, did you see what I did? What we talked about in class today. Do not do. 6t. And so I get t equals 14/6 or 7/3. So the acceleration is 0 when time is 7/3, but I want to know the velocity at that time. So the velocity, we could call it x prime. At that is, so t minus 7/3, just kidding, other way around. Silly Torres. Let's try that again. 7/3 minus 3, there's the first parentheses, and 3 times 7/3 minus 5. And so I get negative 2/3 times 2. So the velocity is negative 4/3. And I think this was inches or units. I forget. It didn't actually say, so we're going to say units per second. And so on this next one, I have some clues. I feel like this is Blue's Clues, and I am writing them down in my handy dandy notebook. So initially at rest tells me when time is 0, that its velocity is 0. And then they give me the equation or the formula for acceleration. And then they tell me at time is 0 what the position is. So s of t is 0 when t is 0. So lots of Blue's Clues. So let's see. I'm supposed to find the velocity and position functions. So I know to get to velocity, I can take the integral or antidifferentiate the acceleration. And the antiderivative of cosine is sine. So my velocity function is sine of t plus c. And so now, of course, this is general. So I would like specific, but I can use the, remember, again, this is velocity, if I squeeze this. And so the velocity is 0 at time equals 0. So that would be sine of 0 plus c. And sine of 0 is 0, so now c is 0. So now my specific velocity is just sine of t plus 0. So I don't need to write that. And then in order to get back to position, of course, I want to take the antiderivative. So the position function says go back a step when you have velocity. So we're going to put the velocity function in here. And then if I take the antiderivative of that, the antiderivative of sine is negative cosine. And again, my general solution has the plus c, but I know this information up here, so I can plug in 0 for position and negative cosine of 0 for t. And of course, cosine of 0 is 1, so that's a negative 1 plus c, which means c is 1. So my specific position is negative cosine t plus, did I solve that correctly? Oh, whoops. This was supposed to be a 3. So this over here is really a 3. Ooh, that's my bad. So down here, I gotta put 3's in here. And so I get C equals 4. So plus 4. And there's my specific position. So I found velocity and position.